Hello everyone, welcome to my channel. So in this next video of sorting techniques and algorithm, we will learn about insertion sort. So insertion sort is basically a sorting algorithm that places an unsorted elements to its suitable position in every iterations. Okay, it's like when we play cards and then we sort cards in our hands. Okay, so it works similarly in that way. So we can assume that whenever we play that game of card, the first card is already sorted, or I would say the first card is the smallest, and based on that card we do the comparisons. So on that comparisons we basically checks with that first card if that element is smaller or greater, and then we basically do the swapping. So if the unsorted card is greater than the card is in our hand, then it will be placed on the right, otherwise it goes to the left. So in same way, other unsorted cards are taken that are available, and we put them in their right place. And a similar approach is used by the insertion sort. Okay, so we use insertion sort here. So let's see the dry run of insertion sort, and let's take an example and let's start. And we will take an array first. So our array would be 9, 5, 1, 4 and 3. Okay, so the concept in insertion sort, like I have told you, we will treat it like a pack of cards we are playing, and we will consider the first element as always sorted, and the rest of elements are unsorted. Okay, so we will consider this element as sorted, and we will compare this elements with the unsorted part, and based on this comparison, the sorted part or the sorted array size will increases on every iteration. Okay, so we consider the first element as our key or as our current element in the program, and based on this element we compare with the unsorted part. So in every steps we consider the element, compare it with the other element, and do the algorithm. So to reiterate or to reiterate the insertion sort, here we make comparison with key. Key is would be the next element. Key is comparing with the right hand side. Okay, so we put the sorted elements on the left hand side. So we check if my sorted is greater than the key. So let's suppose my key is 9, and I will compare, is my 9 5 greater than 5? If yes, then I will do the swapping here. Okay, now let's do the run. So in first iteration or in first step I will compare. So my 9 is greater than 5, I will do swapping. Now it comes as this. Now in step 2 I will again compare my 9 with 1. My 9 is greater than 1. Yes, it is. Then I again do 5, 1, 9, 4, 3. Then I compare 9 with 4. Yes, it is greater. Then again I compare 9 with 3. Okay. Now it does in the first iteration. Next, I will again increase. Now in this next loop, I will again checks. So here, what I'm saying is, here it is 5, 1, 9, 4 and 3, but I also see that here my 5 is also greater than 1. Okay, then I will swap here, and I'll make it as 1, 5, 9, 4 and 3. Okay, then in this step again it will check 9 with 4. So yes, my 9 is greater than 4. Do the swapping, then it will become like this: 1, 5, 4, 9 and 3. But I can see my 4 is also smaller than this. Then it will become 1, 4, 5 and 9, 3. Now I again compare 9 with 3. Yes, it is greater than, but I see my 3 is here and 9 is here, but 3 is also smaller than 5. Then I'll do 3 and 5 here, but I see my 3 is also smaller than this. Then I swap it and put 3 here. Then the last iteration would be 9. So 9 is placed at the end, and I see my array as sorted, and I get my final array. Okay, so the part that I tell you that in the same iteration we do the comparison with the previously sorted one. I told you that the left hand side would be sorted one. So this comparison that I have told you, I will be explaining you in the program what I was telling you. Now coming to the time complexity of insertion sort. So time complexity, so it in big O of n square, it comes in the worst case of complexity. Means suppose we are uh, sorting an array, and that array is in ascending order and we want to sort it in the descending order. So in this case worst complexity occurs, and each element has to be compared with each of the other elements. You see, I compared 3 with 5 with 4. Okay, so that has to be compared with the other elements. So for every nth element, n minus 1 number of comparison are made. So the total number of comparisons are, I see here, n multiply by n minus 1 of n minus 1, not the square. So it would be n square minus n, and we always pick the largest one. Okay, so it will be the big O of n square in the worst case of complexity. But in the best case of complexity, time complexity, in best case would be when the array is already sorted, when the outer loop runs for the n number of times, whereas the inner loop does not run at all, because the comparison would be fail in that case. So thus the complexity would be linear and it would be big O of n square. Okay, linear is big O of n, and in space complexity it would be constant. So constant is big O of 1, because we are not utilizing any extra array or any extra space, so it would be big O of 1. Now let's go to the coding part and let's see the insertion sort. First I will be writing static void main. Inside this we will be defining our array. So I'll take the same array 954 and 3. Now I will be calling my method. Okay, just the bracket I have put. Okay, so now I will be calling static method insertion sort. I'll place here. Inside this I will be expecting array and n, and I'll just call this method. Inside this I'll pass my array and array dot length. Okay, so inside insertion sort we will start from I equal to 0, the iteration, because we consider it as the first element. Okay, so I'll start from I equal to 0, or I'll start from 1. Okay, so not from I equal to 0, because 0 I have considered it as the sorted one, like I have told you. So I will start it from I equal to 1 and I less than n I plus plus, because I have considered my 0th element as the sorted one. So I have, that is why I started it from the 1. Okay, and we consider it as key or the current element. Okay, so this element I'll consider as my key. Okay, array of I, and with this element I will be comparing my, and next I will be also adding one j, and that element I will be considering as the sorted one. So you see 1 minus 1 is 0, so j is the sorted one, and this, with this I will be comparing my next element, and I'll just use a while loop. And if my j is greater than equal to 0 and array of j is greater than this key, okay, so I'll do the swap. Okay, if my sorted is greater than the next element, I'll do the swapping. Okay, and I will do array of j plus 1 equal to array of j. So my j is 0, 0 plus 1 is 1. So in first element I'll put the 0th one, I'll do the swapping, and I'll just decrement the j. Okay, decremented value. Now move key to its actual position. So after this loop ends, I'll put my z j was initially 0, so it will be like uh, minus 1 plus 1 is 0. Then I'll put in 0 the key. Okay, key we consider as the sorted one. Now let's run this insertion sort program. Okay, I haven't printed the sorted one. System.out.println, and now let's just run this program. So we see our array is sorted. Now on this point, what I have telling you about that comparison, now I'm just running it in the debug mode. So my array here is just defining my n is 5. Okay, and I will consider this position when my n will be 2, because first 2 would be the sorting, just the normal condition. So you see my I is 1, j is 0, key is 5, 5 and greater than 5, yes it is true, do the swapping. Okay, now I come across the second condition 1. So this was the condition. Now my 1 is okay, so j is greater than equal to 0, yes correct. I is 2, so array of 1 is 9. Okay, and 9 is greater than 1, yes it is true, key is 1. Okay, so I'll do the swapping. Okay, so array of j was array of 1, 9 I'll put in 1 plus 1 2 in second. Okay, so here my 9 will come and it will remains 9 because I haven't placed key here. Okay, but I'll just decrement j to 0. You see now 0 is greater than equal to 0, correct. Array of 0 is 5, 5 greater than key, 5 greater than 1, no it is not, then just skip it. Okay, 5 array of 0, 0 was 5 and my key was 1. Okay, just 5 is, oh yes, it is correct, 5 is greater than 1, sorry. So it comes inside the loop. Now array of j is 5, so I'll put 0 plus 1 5 here, you see here, and I'll again decrement the j. Now j is minus 1, so it is out of bound, so it will not consider this condition. And now key is 1, 1 where would it put? Array of j is 0. Okay, so not 0, minus 1, because we decremented here, minus 1 plus 1 0, so it will put my key in 0. Now again comes the condition 4. Now see, 4 n is great, 9 is greater than 4, correct. Just do the swapping, so I'll put 9 here and decrement j, so j now will be 1. Now again j is 1 is greater than equal to 0, correct. Array of j, array of 1 is 5, 5 greater than the key was 4, yes it is correct. Again inside the loop, array of j 5, put in 1 plus 1 2, so here I will put my 5 and decremented 0. Okay, 0 greater than equal to 0, correct. Array of j was 0 was 1, is my 1 greater than 4? No, just come out of the loop and just put key in 0 plus 1 1, so my key comes up here. Okay, so you can see in this way we will do the insertion sort and our program will run. So I'll just stop this program and I'll just see the output and show you guys the output once again. Okay, so this was the our condition where you have this 5 9 1 and 4 and 3. So after first iteration, it's like 5 9. Okay, so first was 9, then 5, then 1, then 4, then 3. So after the iteration it becomes 9. Now in this iteration this becomes interesting. 9 was greater than 1, so 1 automatically comes up here and 9 here, but I see 1 was also smaller than 5, so 1 should be comes here, and this became 1, 5, 9, 4 and 3. Now 4 should come here, but 4 is also smaller than 1, so 4 should come here. 3, again the comparison goes on. So in the while loop it till that becomes -1, because 0 greater than equal to 0, we put up that condition. So in this way we do the insertion sort, and we just sort the array. So we haven't utilized any other extra space, so that is why the size of the or I would say the space complexity was big O of 1. That was the constant time complexity, and best case time complexity was big O of n. That was the linear complexity, and worst was big O of n square, because we are running the loops twice up here. Okay, so that's it for today, guys. Thank you.